Hello, my name is Meor, and today I'll be sharing about getting started with text generation with Cohere. There are three main items that we'll cover in this session. First, we'll look at how to prompt a text generation model. We'll first understand what a prompt is all about, and then we'll see how it can be applied on two types of models that are available on the Cohere platform. Next, we'll look at how to control the model's output that you get with a number of parameters that are available at your disposal. And finally, we'll look into a few prompt and application ideas so that hopefully you can get started on your ideation for your projects. We'll look into a range of use cases that are possible with a text generation model, and we'll also look at the range of teams and industries where this can be applied. First, how to prompt a text generation model. So there are two main ways on how you can influence the output of a text generation. So when you work with a text generation model, you provide an input, the model will process the inputs that you provide, and then it will provide a response. So there are two ways and there are two parts where you can affect what output that you want to see and the response that you're going to get from the model. So the first is prompt design, which is what we're going to cover right now. So prompt design is at the heart of working with large language models. It is important that you come up with a good prompt in order for you to get exactly what you want on the other end, which is the output that you get from the model. So the prompt is what you create and what you provide to the model as an input to provide a context for the text that you want the model to generate. It is both science and art. So the good thing about it is that while there are a number or a few ways that we know in general that how prompt design works, but at the same time, on the other hand, there's also a lot of room for imagination, room for creativity, room for experimentation. So that means there's a lot of ways that you can play around and experiment with prompt design so that you can come up with exciting applications for your project. So with Cohere, there are two types of generative models. First, the first type of model is the type of model where you prompt by instruction, and the model that you use for this is called command X large. We'll go into the details on how you can work with this model and the rest of the models in the next part in the subsequent sections. We'll also talk about the other type of model, which is the group of models that you provide examples for it to generate the kind of output that you want to generate. So this family of models include the X large, large, medium, and small models. So let's talk about the first one, prompting by instruction. So in simple words, you're telling the model what to do instead of showing it what to do. For this, use the command X large model that we talked about just now. And the kind of output that you get is more open-ended, and there's going to be more variety in the output format compared to the latter type of prompting, which we're going to look at after this. So it is very simple. If you look at the diagram, what you provide is a set of instructions. It can be a very simple instruction. It can be a very detailed instruction. It depends on what you want to get, and the model will generate the output for you. So let's look at the simplest possible instruction that you can provide, which is just a one-line instruction. So in this case, what we are doing, so if you look at this screenshot, this is a screenshot of the playground that we'll actually go into in a short while. But for now, we'll just look at this screenshot for this first example. So this is the playground where you provide the input and you get the output in bold. And as you see on the right hand side, you have this command X large being the model that is being used. So the simple instruction that we provide here is write the story plot about a writer who becomes trapped inside her own book. And the model duly returns the plot that, if you go through, it looks very plausible, talks about the writer, let's say the first sentence, as a writer, she had always loved the idea of being able to escape into her own world of fiction, and it continues to talk about the plot. But so what you can see, the plot that's been generated is good enough, but probably what you need to provide is something that is a bit more specific, because if you look at generated text is it just continues, but there's no specific way of concluding the plot. So in this example of a fiction writing, so you may want to provide further instruction if you want to generate a story plot. So what you may want to do is to tell the model specifically now with an additional instruction to split the plot into the following story arc. So you have the exposition, rising action, climax, falling action, then resolution. And then the model understands what the instruction tells, which is writing the plot using this story arc, and then it provides this plot from start to finish according to the different sections that you provide. So if you look at how we can use these prompts, if you keep on layering your prompt with more specific instructions, you will get an output that is closer to what you want. So there's no limit on how long the prompt can be. So there is an overall limit of 2048 tokens that includes the input and the generated model, generated output. So one token is roughly, one word is roughly 1 or 2 tokens. So altogether there are around 2000 tokens that you can have in one generation. But yeah, so you have a lot of room to play. So you can have a prompt that is as specific as possible according to what you want. So let's look at the playground with another example on how you can do this. So in this case, so this is how the actual playground looks like. So you have the main window that you saw earlier, and this is the right pane that we'll cover later on what are these parameters about. And on the left, you have these presets, which are the prompts that have been saved. So in this example, I've saved one prompt, which is add copy, a very simple one line instruction, generate a social add copy for the product wireless earbuds. So in the same way that we saw earlier, so it generates this add copy according to what we need. This is great, but perhaps you want to be more specific. And here I have another preset that I've created. So the copy consists, I've added another line of instruction. The copy consists of 4 parts: attention, interest, desire, action, following this AIDA framework that is common in copywriting. So hopefully the model will be able to generate an output how we want it to be. So yeah, it doesn't finish because I've set the maximum number of tokens to 100. So if I keep on generating to more outputs, so you can see that now it is generating this copy according to how we want it to be. So you have seen 2 examples on how you can achieve what you want in terms of the output by layering your instructions to be as specific as possible. And this is just one example. There are many more ways you can play around with the prompts. Another example is to have instruction plus some context. So this example, the context that we're talking about here is a product in which there is a description about the features of the product, which is an app that automatically transcribes meetings. So what we want for the model to generate, which is the instruction, which is to turn the following product feature into a list of benefits. And to be more specific, group them into 3 types of benefits: functional, emotional, and social. Okay, so now you see that it generates this output based on a context and instruction that we provide. So this is what we see here, where you can have one simple instruction, you can have more specific instructions layered on top of each other, and you can also have a format where you have a set of instructions or a line of instruction plus the context that you want the instruction to refer to. So these are like a number of ways on how you can construct or design your prompt. But there are many more ways. Again, the good thing about it is that it's a combination of imagination and iteration. So the whole plan is for you to keep on iterating, think about new ideas, just play around with the playground, and hopefully you'll be able to get to what you want to get out of the model. So the other type of model that we have, as we discussed earlier, is a model where you prompt by example. While the prompting by instruction that you saw just now was quite straightforward and quite simple, because you can even start with a one line of instruction. Sometimes you want the output to be a bit more specific and to be of a similar kind of pattern, tone, especially when you're generating it in something many times. Let's say you want to generate product descriptions of thousands of products. So you want each of the descriptions to be of a similar style. So in that case, if you were to use that earlier model that we look at just now, you can still achieve, you may still be able to achieve what you want, but with this other option is going to be a bit more simpler for you. So let's look at how you can do that. So instead of telling the model what you need to do now is to show the model what you need to what it needs to generate. So these are the 4 different models that are available. As a rule of thumb, the larger models provide better quality output, while the smaller models provide a faster latency. So that means you get a faster generation once you click on generate. So the output is more close-ended and the output format is more predictable. So the general format that works well is you provide first a description of what this whole prompt is about, and you provide an example on what you want the model to generate, and then you have a stop sequence to each of the examples. So stop sequence is a set of sequence that you can provide to the model to indicate that you need the model to stop at a certain point. So let's look at this via an example. So in this case, we have this product description where, given a product and keywords, this program will generate exciting product descriptions. And we give 2 examples of a monitor and a surfboard, and we want the model to generate the description for this headphone. So we provide keywords and the model then generates this output, which is of a similar style with the other 2 that we have provided. So in this case, we can keep on generating similar style for the rest of the products that we have in the list in this case. Another example is haiku. So with haiku, typically what you want to generate or to get is typically 3 lines, or 3 lines where roughly they are of a similar length. So here what you provide is a few examples of haikus, and then here you provide a few keywords, write a haiku about software and magic, and then the model generates this haiku according to the pattern and examples that we have provided. Another application would be like in chatbots. So this is an example where it is a user talking to a fantasy wizard, where we want to create the persona of the chatbot that someone is talking to. So here the persona we're talking about is a fantasy wizard that provides an answer to the questions that a user is asking. So you can create chatbot personas by providing a few examples of what kind of tone, what kind of style that you want the chatbot to write about. So we have looked at how to prompt the models via these 2 ways of prompting. So the second way on how you can control the kind of output that the model generates is via the parameters. So you see the parameters on the right hand side of the playground. There are a few of them, and they can be grouped into 3 main categories. So first is when to stop. So the most straightforward is you specify the number of tokens. So as we discussed just now, roughly speaking, 1 word consists of one or two tokens. So this is what the model does as it takes the inputs that we provide, turn it into tokens, and then returns the text and output. So we provide the maximum number of tokens to represent the number of words roughly that we want the model to generate. So the other way that we have also covered earlier is stop sequences. So for example, if you provide double dash or any set of sequences that are typically not a sequence of text that you see on a normal generated text, you can provide that to indicate that this is where the model should stop generating. And if you are talking about the instruction the command model that we looked at earlier, where we prompt it by instruction, you can because it doesn't have a pattern of examples, so maybe we can't provide this dash or set of symbols to show when to stop after each example is being generated. You can use like a period character, new line to indicate that the model needs to stop the moment a paragraph has been completed or a sentence has been completed. The more interesting one is to the set of parameters that you can control and modify to tell the model whether to be more creative or more predictable. But before looking into the parameters, let's understand what likelihood is, because everything revolves around likelihood when you play around this set of parameters. The concept is actually very simple. So when you provide a prompt to the model, in this case, I like to bake, the model will decide among all possible tokens that it sees, in which case, in this case, is in the thousands, which tokens are more likely to be generated after this sequence of words of I like to bake. So in this example, we see that cookies is at the top of the list, which is the most likely token to be generated. And somewhere down the line, you also get other tokens, in this case, for example, chair, which is not very likely that a chair will follow a prompt of I like to bake. But it's there, and there's still a chance for the model to generate this word and any other words other than the topmost token with the highest likelihood. And the whole point of adjusting the parameters is to increase or decrease the chances of these other tokens to appear after this prompt. So how do you do that? So first is with the parameter called temperature. So if you look at this is a rough illustration on how it looks like. So if you look at the center illustration here, you see the list of probabilities. So vertically, it is a list of tokens. So it will go on until all the possible tokens are listed. So if the initial set of probabilities are like this, if you increase temperature, what you do is that you somehow nudge the other tokens to have more higher chances of being being selected as the next token. So whereas if you reduce the temperature, you reduce the chances of these other tokens, and you have the topmost token to be almost always being chosen every time. So that means if you increase the temperature, it will be more random, but if you reduce the temperature, it will be less random. So in other words, increasing temperature can be associated with the model being more creative, and decreasing it, making the model more to be more predictable. So the other set of parameters are top K and top P. So whereas temperature looks at which token to choose, top K and top P looks at how many tokens to choose from. So if you reduce the number of K, which is the number of tokens to be considered, let's say you just select K as 3. So only the first 3 tokens will be considered as generation, whereas if you increase it, you're opening more options for the model to choose from the range of tokens available. So similarly, if you increase top K, the selection is wider, which means that chances of more random output is higher. And if you decrease top K, the output will be less random. Top P works in a similar way to Top K, except that while Top K looks at the counts of tokens, Top P looks at the probabilities, sum of probabilities of these tokens. So similar way of filtering this, just a different way on how it is being calculated. So yeah, let's look at one example. So here we have, with the XLarge model, prompts that generate startup idea given an industry. So what we have now is a few examples of industry, startup idea, and a startup name, and we want the model to generate an idea given this industry, which is productivity. So here are the settings for temperature, Top K, and Top P. So for Top K, what you see is 0, which means that Top K is not used. That means all possible tokens are available to the model. So let's generate with this current settings with temperature 0.4. Okay, personal assistant that helps you schedule meetings. Fair enough. So what you want to do now is, let's say you want the model to be more predictable. So what you do is to reduce the temperature, and actually you can even change the Top K to 1, which means that you want the model to be very deterministic. Like what should happen is that every time it should generate the same thing. So here with temperature 0 and Top K of 1. Okay, so a tool that helps you manage tasks and projects by automatically creating Gantt chart. So if I generate this again, I get the same thing, the exact same thing, and no matter how many times I click, I'll get the same thing, because what I've done was to reduce the temperature to 0 and Top K to 1. So this is being as is deterministic. That means as predictable as it can be. But if you want it to be a bit more creative, let's say 0.8 as a temperature. So the range is between 0 and 2. And Top K, let's change it back to 0, which means that all tokens are possible. Here now you get new ideas about a task management app. Let's make it a bit more, let's say 0.9. Okay, a keypad that can be set to thousands of different shortcuts based on each user preferences. So it starts to explore like very broad range of ideas. What I've done earlier that I'll not cover here, but if you go within this range of 0.2, 0.3, the ideas that normally would come would be typically to-do lists and your typical productivity, personal productivity applications. But as you increase the temperature, it starts to get more interesting and more creative. So of course it depends. These settings depends on when is suitable to be used. In this case, when you want to generate ideas, maybe you want to get it to be more creative, but in other cases where, for example, you want to summarize something, maybe you want it to be more less creative and more predictable, and according to how you want it to be. So that's how you use this set of parameters to control the creativity of the model. And finally, there is a set of parameters that you can use, frequency and presence penalty, to reduce the repetitiveness of the output, where it gives a penalty to tokens that have been present before. So you can also use this to your advantage. And finally, we look at a few prompt and application ideas. It helps to understand, or when you want to ideate on stuff to build, to understand what the model can do, and at a high level, what the model can do can be bucketized into these four broad range of use cases. So the first is generate, which is basically the biggest portion and the most that we have seen in the examples earlier, where we just provide a prompt and it just does a completion or continuation or response to the prompt that you provide. But there are also three other specific ways you can utilize prompt design to create different kind of use cases. For example, to summarize. So in this case, you provide a context, you provide an instruction. For example, if you're using the command model, and then the model will generate the summary. You can also use it for rewriting or paraphrasing a text that you provide just by changing the prompt. And finally, by designing the prompt, you can also get the model to extract information from existing text. So we'll look at a few examples in a short while. When it comes to teams, there are many teams, industries, and verticals that all these can be applied. But broadly speaking, you will see a lot of out there teams around copywriting, social media, productivity, like writing emails, creative writing, of course, that we have seen in the first example earlier, and it goes on. There are many possible teams that you can apply text generation into these verticals. So if you already have ideas on what to build, then that's great. But if you don't, maybe a good way or a good exercise that you can do is try to match or try to mix and match and try to map between the kind of use cases and the kind of teams that you would like to go into and try to ideate based on those. So there are so maybe that's a good starting point, and let's look at specific prompts and examples that maybe can help you get started with ideation. So the first is summary that we talked about just now. So in this case, it's using the X-large model. So we provide a couple of examples of a passage and the TLDR summary. And yeah, with this, the model will generate the summary based on the passage that we provide, which is about a phrase warning in this example. So when it comes to rewriting, you can think of it in terms of many different ways, like correcting transcriptions, correcting spelling mistakes and grammar and things like that. In this example is to rewrite blog titles to make it more interesting. So this is using the command model, which is where here we are telling the model to suggest 3 alternative titles with a better marketing copy for this title that we have given, learning to play chess. So yeah, surely it can do better. So it provides 3 examples or 3 ideas on blog titles that can replace our original one, where the tone is inspirational, where we provided it as part of the instruction. And finally, extracting entities from text. So in this case, from legal agreements. So we can set up the prompt in such a way that we give examples of extraction in many different ways. So in this case, it's extracting entities from legal agreements, but you can apply it, for example, for extracting a list of skills from resumes, or extracting movie titles from a passage or description, or extracting keywords from articles. So there can be many ways you can apply this extraction use case using text generation models. So let's look at a few more other examples. This is a brainstorming use case or theme, where in this specific example is generating the business model canvas, where if you want to brainstorm about this product, which is a satellite broadband service, one way you can do this is using the well-known business model canvas, where you are splitting the items into 9 different buckets. So you can just provide this to the model, and with this prompt, it does work. It provides this different information. It gives you ideas on what value propositions, for example, that this service provides, the customer segments, channels, and actually the list goes on, and it completes until all the 9 buckets have been generated. Another example is generating a pitch deck. This is using the command model, generate a pitch for an AI chess tutor, and we specify what must be included in the pitch. So problem, solution, features, and so on, and we get this generated by the model. Another interesting application would be turning keywords into email. So when it comes to productivity, it will be good to just tell the model roughly what you want to write, and then it will complete the full passage that you want to create. So here we provide, using the X large model, we provide a few examples of keywords and the full email, and we get the generation here for a launch of new fitness watch series. Yeah, and finally, creative writing. We have seen one example earlier. Here it is an example of a Victorian style writing, where we're asking the model to generate a different kind of writing, which is following the Victorian style of a simple phrase of "I'm feeling okay." So here you get this very elaborate and beautiful expansion of the same idea, but in a different style. So in this case also we provide a couple of examples of like a normal English phrase with the Victorian style counterpart. And that's about it. I hope that has been helpful, and happy hacking.